Hi everyone. In today's challenge, we are going to solve this problem. The problem name is maximum running time of n computers, and problem number is 2141. Alright, guys. So first of all, what we are going to do? We are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming. Fine, guys. And guys, if we want to have a look on the solution, which I'm going to write in this video, I will share the link in the description. You can go through that particular link and you can find all the solution which I'm going to write in this video, right? Alright, guys. So now let's see what this problem says. So let's understand the problem statement. So guys, problem says you have n computer. So we are going to have n computer and you are given the integer n and the zero indexes integer array batteries. So guys, it's clearly mentioned that we are given one thing that is nothing but integer, that is nothing but n. So that will tell us that how many computers we have, right? Second thing, we are given an array of integer, right? Array of integer, that name is nothing but battery, fine. Where ith battery can run a computer for battery of I minutes. So let's say if our arrays look like 2169, so here 2 is nothing but we can say this 2 is nothing but the time for that particular battery, that how long this battery can run the computer, right? So if this is 2, that means this battery can run a computer 2 minutes for 2 minutes, right? And this battery can run a computer for 1 minute, right? So this is the simple meaning of battery array, right? Fine. You're interested in running all n computers simultaneously using the given batteries. Now what is the challenging part here? The challenging part is nothing but we have to run n computers simultaneously. Not like we are running a one computer, second computer is off. No, if there are four computers, so four computers should run simultaneously. No computer should be off, right? I hope it makes sense. Fine. Initially, you can insert at most one battery into each computer. After that, and at any integer time moment, you can remove a battery from a computer and insert another battery any number of times. So simple thing, guys. Let's say this computer is running, right? So this computer is running one. This is computer one. This is computer two, right? And we have seven or six battery, more than five battery, right? Let's say that. So now this is that if this is running on a battery one, right? And that battery one has been, let's say battery one time was 2 minutes, that can run only this computer for 2 minutes only. So let's say battery one is discharged, completely discharged. So we have to replace with another battery, right? So replacing that battery does not gonna take any single unit of time. So you can assume that that is just quick, not taking a single unit of time. So it's, you can see here, guys, uh, the inserted battery can be totally new or battery from another computer. You may assume that the removing and inserting process take no time. It's not going to take a single unit of time. If this is discharged, you can replace with another battery. So you can say I'm replacing battery 2, so you can replace it. There's no gonna be, this computer will never gonna off, right? This will run simultaneously. That's simple meaning, right? And we can also replace with another battery that we will discuss later on, right? Fine. Note that the batteries cannot be recharged. Like if battery one is discharged, so we can't recharge this battery, right? So it is discharged, that means discharged, we can't use it anytime anymore, right? Fine. Return the maximum number of minutes you can run all n computers simultaneously. So the main part is nothing but this one. So what we need to do, we need to just find how long we can run all n computers simultaneously, right? So as you know that we have to run computer simultaneously, so how long we can keep continuing this part, right? So by discharging or by changing the battery, by using another batteries, anything else, right? Whatever we can want, we can use, right? So let's see with example one, then we are trying to understand what this problem say. So guys, in the example one, we have this battery, right? This battery is array, we have three battery, that means, and n is 2, and 2 means nothing but we have two computer. In the example or in the image, you can see, guys, we have two computer, right? These are two computers we have, and initially we have a three battery, and all three battery can run a computer three times or 3 minutes, right? Fine. So this is the interesting part. Let's see how we can solve this. So let's say this is computer one and this is computer two, right? Fine. And I have three batteries, so I have this battery 3 unit of time, this also have 3 unit of time, and this also have 3 unit of time, right? So what I'm going to do, I'm going to say this battery one, this battery two, this battery three, right? I'm going to say this computer one should take now battery one, it should run on battery one, it should also run on battery, we can see battery 2, right? So both have 3 minute unit of time, right? So they can run this computer also 3 minutes, they can also run this computer for 3 minutes, right? Fine. But we need to find how long maximum we can keep running this both computer simultaneously, right? So what I'm going to do, I'm going to say fine, it's run for one computer for 1 minute, right? So I'm going to remove this battery after 1 minute. So I'm going to remove this battery, I'm going to replace with battery of 3. So battery one now remove have, now the we can say time is 2 only, right? So because 1 minute it has already run for this C1 computer, and battery 2 is going to have time, let me say 2 now, right? Battery 2 is also going to have a 2 unit of time, right? Because they both have run a computer for 1 minute, right? Fine. Now what I'm going to do, I'm going to say it's cool. So what I'm going to do, I'm going to say okay, I replace with battery what I replace battery 3, right? So I'm going to keep run again. So the battery 3 is going to run 1 unit of time, battery 2 is also going to run unit of time. So battery 2 is going to now have a value nothing but 1. So because it has run 2 minutes, it has run 2 minutes for computer 2 now, right? So battery 2 will have now 1 minute and battery 3 will have now 2 minutes. I hope it making sense, right? You are getting this part, right? Battery 1 is run only for 1 minute for computer 1, so it's now have 2 minutes only. Battery 2 has run for 2 minutes this computer, so it now have 1 minute of time left. And battery 3 has run only 1 minute, so it's going to have 2 minutes of time left. So once we are done this part, now what I'm going to do, I'm going to say just replace with battery 2 with the battery 1 again, right? So now 2 will minute of time this computer will run, and 2 minute of time this computer will run, because both have now 2 2. So complete unit of time we are able to run is nothing but 3 time. Currently we are able to run 3 time. I hope you are making you are getting this particular part. So completely we are able to run how much time? 3 minutes of time. Are you getting the? No, 3 or 4, sorry, because we can see initially this was run for 1 minute. So just let me take, this is going to be a little complex for you, so not you, for me as well. So I'm just simply telling this part. So initially we were having a 3 3, right? So just a little. So guys, C1 and C1, these two were computer. We have taken B1 and B2 here. So I have taken B1 and B2 here. I have run B1 for one unit of time. So now we will B1 will have two unit of time left, and B2 will be running. B2 will also be 2 unit of time left, right? So we have run for 1 minute. So 1 minute is taken, right? So I'm gonna write 1 minute is done. I will come next, and here what I'm gonna do, I'm gonna say fine this C1, this C2. I'm gonna replace after 1 minute B1 with B3. So now this will gonna run on B3 battery, and this C2 will run on B2 only, right? So B2 was having a 2 unit of time, right? And B3 was having a 3 unit of time. So this ran for 1 minute again. So this ran for 1 minute again. Now B3 left with 2 unit of time, and B2 left with 1 unit of time. I hope you are getting this part right. So now 1 minute is also done. That means completely 2 minutes is done, right? So they both these both computer run for 2 minutes simultaneously. Now what I'm gonna do after 2 minutes, this C1 computer, this C2 computer, I'm gonna say this is nothing but this B3 is going to remain same. This computer 1 will run B3 only, but think about this. This B2, computer 2 will not run on B2 now. It will run on B1. As you can see now in the image as well, and here as well, B1 is having a 2 unit of time left, and B3 is also having 2 unit of time left, right? So you can see guys, this is gonna run for 2 minutes, right? After that battery will discharge, they will not able to run again, right? But total unit of time they could able to run is nothing but 1 and 2. This means nothing but total 4 unit of time they were able to run simultaneously. So we are going to return answer 4. So we can at max run this computer simultaneously for 4 minutes, not more than that. Because now if we are going to see this B1 will be 0, B2 will be 0, B2 will also going to be nothing but equal to 0. But B2, not B2, B3. But B2 is having a 1 unit of time. But either we can give this B2 battery to C1 or C2. But we can't give both C1 and C2, right? But they need to be simultaneously, right? So we can do like we can give this battery to C1, and C1 computer can run 1 minute extra. But that time C2 will be shut down, right? So we can't do that part. We have to run both computers simultaneously. So we can say at max we can run 4 in minute, right? So we are going to return answer 4. I hope this you are getting this particular part. This is just a simple example, right? So we have next battery, or next example, not battery. So in next example, we have this battery which nothing but we have a 4 battery, right? So there are 4 battery total, all having a 1 unit of time, and n is 2. We have 2 computers, C1 and C2. Now we can give this one battery B1 and B2 to this. So they can run only 1 minute of time, because both battery have a limit of 1 minute. So after 1 minute, we are going to replace with next 2 battery. So they are going to run also 1 minute, C1 and C2. They are going to run on B3 and B4. So they are also going to run for 1 minute, right? Because they also have a limit of 1 minute. So total we can run for 2 minutes only, right? Not more than that. So we are going to return answer. I hope guys now you understood what we have to do in this particular example, right? So we are given a battery, we are given a n is nothing but total number of computer we have. Battery nothing but in each on each index we are going to have the time at max that battery can run for a computer, right? Fine. So that is given us, and we have to find maximum number of time, maximum number. What is the maximum time we can hold a computer when both all the computers are running simultaneously, right? So now guys, let's see how we can solve this problem. What is the logic we are going to use to solve this problem? We have seen the problem, problem statement, right? We have understood what the problem says and what we have to do in this particular problem, right? Now let's move to the logic part. In the logic part, we are going to see how we can solve this problem. So first of all, guys, we are going to use here binary search, and why and how we come to know that whether binary search is helpful or not here. See, uh, we are just going to say here, if our battery, not if our computer could able to run. So just what we need to find, we need to find time, right? If our computers, all the computers, right, for all the computers is fine with running, right? If all the computers are running simultaneously for 6 minutes, let's assume this part, right? If our computers are running for 6 minutes simultaneously, that means rest of the minutes, right, which are like 5 minutes, 4 minutes, they will definitely run simultaneously, right? But for more than 6 minutes, or that means nothing but 7, 8, 9, or 10, anything, or 12, so that means there is no guarantee that this computer will run simultaneously or not, but we have a guarantee that for less than 6 minutes, definitely our all computer will be running simultaneously, right? I hope you are getting this part. So just simple thing, guys. If our computers, let's say there are six computer, right? So let me write here six computer, or let's say five computer. If there are five computers, and all these five computers are running simultaneously, when for how long? For 10 minutes. You are given that five computers are running simultaneously for 10 minutes, right? So that means they were also be running simultaneously for 5 minutes, right? It's not like that they are running simultaneously for 10 minutes. That means they must be running simultaneously when the time was 5, right? I hope it makes sense, right? So if you are given this particular scenario, then you can easily find this particular part, right? So if computers are running simultaneously for 10 minutes, that means there is guaranteed that less than 10 minutes they will definitely running simultaneously. But for more than 10 minutes, don't guarantee that they will be running a simultaneously or not, right? That depend on the next time, right? So we can say for 12 minutes we don't know, but for 6 minutes they must be running simultaneously, right? Now, okay, and what we are going to do with this? So how this is going to be helpful? So guys, if this is the case, then we can move to the right side. We can say fine, if they are running a simultaneously, so now move to the right side and try to check from the right part in this we can say space, try to check when they are running the maximum time. So what is the max time till that all computer were running, right? But if it is not running, if five computers are not running simultaneously for 10 minutes, so what we can say from that, we can say that for the next all these minutes, they will definitely not gonna run, right? When they are not running simultaneously for 10 minutes, they must not be running for 12, 14, 60 minutes simultaneously. But there is a guarantee, there is, we can say, a chance that they must be running simultaneously when the time is less than 10 minutes. I hope you are getting this part. So we have a time limit here. Here's zero time, here is, let's say, 100 time, right? So there are six computer, right? So, or five computer. So here we, let's say we have this thing, this line is not right, so we can say fine. So here nothing but, let's say, 50. So if we know that all the computers are running at till 50 minutes, right? Are running a fine simultaneously till 50 minutes. So we can move to the right side. We can say fine. There must be a time like that could be 75, 78 when that computer was running, right? Simultaneously, and after that they will not run. So we have to find that time, right? But if it is not running at 50 only, right? If it is not running till 50 simultaneously, so we can say definitely on the right side they will not gonna run simultaneously. So we have to move to the left side, and we have to find from this particular space that whether they are running simultaneously or not, and what is the maximum time till they are running simultaneously, right? So we found that 25, yeah, they are running simultaneously. So we'll move to the right side. We will move to in this direction. So we found that 30, they are running a simultaneously, but 31 they are not running simultaneously. So we are going to return nothing but answer 30. I hope you are getting this part. If still not getting, don't worry. Let's see this here. So in the first example only, guys. So we have a what we are going to have. So guys, in this first example, we are going to have these three battery, right? And we are going to have two, right? N is two, means two computers are there, and time is nothing but three. Battery is three. So now let's see how we can solve this one with our logic. So let me write here. N is nothing but two computers, and battery is nothing but three, three, three. There are three battery with three unit of time, right? So at max, how much computer? So first of all, let me make a range. So range is going to be nothing but, we can say, zero, from zero till how much? So for zero, how much till it's going to be range, right? So let's see that part. So at max, the unit of time is nothing but, we can say, 9, right? Total, if sum up the battery time, so we are going to get a total time is 9, right? 9, and we can divide it by 2, right? So what we are going to get? We're going to add 8. So we can say at max, 8 unit of time we can run this computer, right? At max, 8 minute of time we can run these computers. Fine. So now what we are not 2 here again, 9 to this is 4, right? At max we can run 4 unit of time, right? Now what we are going to do, we are going to say fine. So we have a low, we have high, we have our range. Now we are going to run a binary search on this. So how we can run a binary search? So we are going to find mid, that is number 2. We are going to check, can we this two computer running simultaneously for 2 minutes or not? So we will find a true, right? So how you can find a true? You can see we can find a true, because we can say this battery can give 2 unit of time to this computer. This battery can also give 2 unit of time to this computer. So computer 1 can take first battery, computer 2 can also take one battery, right? So b1 and b2 they can take and they can run for 2 minutes. That is cool, right? So when we can say fine, it's true. So we're not going to move to the left side because we guaranteed that for one also it's definitely going to run simultaneously. So we will move to the right side. So now we have this space. So now we are going to find between this. We are going to find mid. So it is nothing but 3. So we are going to find, okay, check whether we are these two computers running simultaneously for 3 minutes or no. So we found out that we can give this to C1, this to C2, and the both computer can run simultaneously. So this is also true. So we are not going to move to the left side. We will move to the right side. We can find this mid. So this mid is nothing but going to be 4 only. So we can say fine. We have 4. So now check whether this is working fine or not. So this both computers working fine or not, simultaneously or not. So we found out that for 4 also it's running a fine. So we are going to return nothing but answer 4 because we reach out of bound. So I hope guys you understood the basically scenario of the minus search. I'm not here to tell you like whole the scenarios, but at least you got an idea what we are going to do. We are going to given a search space which is time, right? So if a computer is running for that particular time, so then definitely or the less for the time which are less than that, so definitely this computer will be running simultaneously. But for right, we are not guaranteed that. But if computer not running a simultaneously on that particular time, so we are guaranteed that for the next of the time it will never gonna run simultaneously. But for left side means less than that time, they maybe run simultaneously, right? So we'll move to the left side. So now let's move to the code panel and see how we can implement this one, right? So I know this is going to be a little complex, but with code you can easily understand this one, right? So what I mean by here, see, first of all, we are going to say low. Initially low is 1, high. High is nothing but simple going to be, I'm with the Python first of all, right? So high is nothing but going to be sum of batteries. And here I'm going to divide by n, right? So this is high range. So I'm just simply use here binary search. While low is less than equal to high, and I can simply find a mid, low plus high, and divide by 2. And after doing that, what I'm going to do, I'm going to say fine, just check if it is possible with this or not. Possible with this mid or not. If it is possible, so what you're going to do, you're going to move to the high is equal to not high, you're going to move to the right side. So you can say low is equal to mid plus 1. Otherwise, you're going to move to the right left side. So high is going to be nothing but mid minus 1. At then you can simply return your high. So let's define this function, possible function. This is going to be really simple, possible. So what we are going to do, we are going to have a mid in this one. So mid is nothing but we can say we are checking for this time, right? So we can say time. So we are going to check now. What we are going to do, we are going to say find total time, or we can say possible time is going to be nothing but sum. You have can do sum of minimum of time, comma we can say uh, let's give it a name value for value in our batteries, right? Fine. And then you can find the computers, which is going to be nothing but total time divided by n, and you can say this computer should be greater than equal to n, right? So you can say return this one. I will tell you what I have done this in return possible function. So just give me a second. Let's see first of all whether it's working fine or no. So you can see both the rest is passing. So let me tell you what this possible function is doing. So first of all, we are taking all the times, right? So let's say we found a mid at 50. So we are going to check at 15 minutes of time, all the computers are running simultaneously or not, right? So what we found? We found that first of all, we checked the total time. What total time we can get, right, from all these batteries. So when time by this, we got total times. Now we are going to check with this total times how many computer can run with this time, right? So we are dividing by n, right? We have to divide by time, right? So each computer will going to take this time, this unit of time. So we have total time this month. So we're going to divide by this time. We're going to get now how many computers are running now. So it will going to give us a computers. So this many computer can run with this given time, right? Now we are going to check if this computer are greater than or less than, are greater than or equal to this given computer. Yes, if it is yes, so return true, otherwise return false. So that means nothing but if we are able to run this much computer with this unit of time or not, right? If we could able to run this much computer with this given time, with this given mid, then return true, otherwise return false. I hope it makes sense, right? So let's try to submit this code. Okay, I haven't done something. It will give an error. I have to use a mid here, not mid time here, right? Fine. Now let's see. Okay, let's see. And you can see guys, it successfully got submitted. So we can easily do this by using a binary search. So simple thing guys, we're just checking out for this part. If it is possible, so move to the right side, otherwise move to the left side, right? And how we are checking this, we are just trying to calculate the total time which we can get from the battery, and after that we are checking how many computers we can run with that total times, and if that number of computers is greater than our given computers or equal to that given computers, then we are going to return true, otherwise we are going to return false. Now let's move to the C++. And here we're going to have int n, not n, low. So we can say long long low, right? Long long low is nothing but we can say equal to what we can give a name, let's say 1 only, right? Long long high is going to be initially 0. We are going to say fine, If it is 0, then we can use a value into value of batteries, and here we can add all this high plus equal to, we can say what, we can say batteries. Fine, so we added all these things. Now once we done this part, now what we are going to do, we are going to say fine, we added, we are going to divide it by n, right? So high should be equal to high divided by n. So now we got a low bound and upper bound. So now we are going to use a combine search. While low less than equal to high, so we are going to get a mid. It is going to be low plus high, and here we're going to say if possible for this mid. So what you are going to do, if possible for this mid, then you can say move to the high is going to be, low is going to be mid plus 1, move to the right side. Else you can move to the left side. So high should be equal to mid minus 1, and then you can simply return high. So this makes sense. Let's define a function here. So function name is going to be long, not long, it's going to be boolean. The name is going to be possible, and we are going to give a data type long first of all time, and then we're going to give a name n, then we're going to give a name vector int, and we can pass a battery as well, as we are defining outer function. And here we're going to pass this whole thing n as well and battery as well. Fine. And here what we are going to do, we are going to say fine, first of all take a variable long total time, which we can get. Initially it's 0. Now we are going to say for int value of time. Fine. And here what we are going to do, we are going to say no time, batteries. So batteries. Here we're going to say fine, our total time plus equal to what, it should be minimum of, and what we can do, static cast and long, and here we can give our, we can say that particular value, and after that we can say our time, right? After that we can say now find how many computer we can run with this total times. So total times divided by we can say n, and after that we can say this should be long, right? Fine. After that we can say simply return computers should be greater than or equal to over n, otherwise return false, right? Let's see whether it's working fine or no, or we have done something wrong with this start this particular part. So we got an error, right? Unknown type boolean. Okay, in Java we use a boolean, here we use a bool only, right? Fine. Now let's see whether it's working fine or no. Okay, we got an error long and vector of int, so it's giving an error here, right? So why it's, so we are having this value and this should not pass, right? So we can convert it into a long, right? So what we can do, we can use a long battery here as well. So I think okay, we have to use value, right? I was thinking about the long, right? So now you can see guys all the rest is passed. So what issue we have done here, so let's see whether it's getting passed or not. So the thing is guys, it's gonna getting a bound of, right? So it's, we have to use the long typecasting, but we got an error over here as well. So it's giving a wrong answer, right? So let's see whether what we have done wrong here. So mid is nothing but this, low plus high divided by 1, possible mid and batteries, low is nothing but mid plus 1. So we are moving to the right side, as we are moving to the left side. So battery, we are reaching to all the batteries, we are adding this value into high, dividing by n, this is perfectly fine. And we come to this part, total time is 0, fine. So we move to this value and we found a minimum, added into total time, so we have to divide. Okay, so issue is nothing but here, so we have to divide by time, right? So now let's submit this one. I don't know why I'm doing this mistake. I see this is a hard level problem. I really, my mind is going a blow up, right? So you can see guys, it successfully got submitted. So we have submitted this one. Now let's move to the Java, right? So in Java, what we are going to do, we are going to say first of all find low. So it should be low, which initially 1, long high, which initially 0, and we have to add all these. So we can see value of batteries, and we want to say high plus equal to value. Once we found highs, then we are going to divide by n, right? Once this is done, we are going to use a while loop, means binary search. While low is less than equal to high, what we are going to do here, we're going to find a mid. So we can say long, mid is going to be nothing but low plus high divided by 2. Then once this is done, what we are going to do, we are going to say fine, we found a mid. We are going to say if our possible, if with this mid we are able to run all the computers simultaneously, so move to the right side. So we can say low is going to be mid plus 1, otherwise move to the left side. High should be equal to mid minus 1. I should be equal to mid minus 1. Fine, and then we can simply return high, right? So this will tell us how many how much maximum time we could able to run all this computer simultaneously, right? So let's define that possible function. So now here we can use a boolean. So what I'm going to do, I'm going to say boolean that function impossible, and here we can pass our first of all long time, not it mean time, and we can pass here int n, and we can pass a battery as well. Fine, and here we're going to say first for long total time. Total time is going to be initially 0, not 9. What I'm doing, I don't know. 4. After that, what we can say, for int value of this battery is, we have to take either we can say just total time plus equal to math dot minimum. We can't use this simple minimum, and here we can pass our either value if it is smaller, right? So if our value is smaller than time, so take this value, that was take a time, right? Simple thing. After that, once we are done this thing, we are going to find total computer. We can run with this total time. So in total computer, so we can say simple computer only. In computers is going to be total time divided by time. And then we can return computers greater than should be equal to time. And here we have to use long, right? Not time. Now let's see whether this we can find or not. I hope it should work, right? So it's taking a time, but we got an error possible. We have to pass 3 parameters, right? Not mid and as well as batteries. Now let's see whether this we can find or not. So I hope guys now it should work. So it's taking a time. You can see both the rescues pass. So let's submit this code as well. And I hope guys it will also gonna submit. So it's taking a time, but it got accepted, right? So you can see it's got accepted. Now let's go to the JavaScript, the last program language, finally. And I'm gonna say first of all, let low is 1, high is gonna be nothing but 0 for in const value of batteries. Here we're gonna say nothing but a high plus equal to value, right? So guys, it's gonna give an error. I know I have given a lot of confusion here, but this is also in JavaScript we have to use big int because this is gonna close this part, right? So we have to use big int, and here I'm gonna use a 0. Fine. So now here I am also gonna do big int, and I have really broke my mind, right? I can't think about this question, how long it took. It is a simple question, but a lot of implementation part, right? So once we done this thing, we are going to say high divided by again begin, right? And here we're going to say begin by n. So once we done low and high, now we are going to use our binary search while low less than equal to high. So what we are going to do? We are going to say find out mid. Mid is going to be nothing but low plus high divided by big int. We can say divided by big int of 2, right? Fine. So once this is done, then what we are going to do? We are going to say fine. We got a mid. Now check if possible with this mid or no. If it is possible, so you have to move where right side. So low is going to be mid plus 1 and not 1. We have to use again a big int. Else high should be mid minus 1. So not 1. Again we have to use big int. So I hope you understanding it what I'm doing here. Big int, right? Fine. After that we can simply return our high, but not high. Again here big number of high, right? So this is going to be begin, but this is not going to acceptable. We have to return by converting it to a number. Fine. Now we are left with nothing but defining a function. So we can say const possible, not const, right? Const possible is going to take one parameter that is mid, and then we are going to say fine. First of all, let total. What we can say total time is going to be nothing but big int of 0. Then we are going to say for const value of this batteries. We are going to say total time plus equal to what we can give math root minimum. What either we can give first of all we have to convert into a number this time, this value number of values, and then we can pass this mid, right? We have to convert into a number this mid, not value, right? Fine. So we can do like this. Fine, right? So once this is done, then what we are going to do? We are going to say fine. At the end, we can say total time, not total. We can say computer. That computer is going to be nothing but total time divided by um, this mid, right? So mid is nothing but time only, right? So we can say divided by time, and this we have to convert it into big int. Fine. So once this is done, then what we are going to do? We are going to say return computer should be less or greater than or equal to over n, right? Now finally see whether we are getting any error or not. I hope we should not get any error, but I'm really worried about this one, right? So we got one error is possible is not defined. So what we have done? Possible. Fine. Second error is nothing what we can say. Is there any other error? Let's see that part. Okay, just give me a time as well. Okay, here we got an error. Cannot mix begin and another type explicit conversions. So what we can say, Okay, so we can convert this into a big int, right? Let's see that part. Now let's see one more time. Okay, so we got now here. Time is not defined. Yeah, time is not defined. We have made only, right? Now, please, it should pass. You can see, guys, both the tests pass finally. So let's try to submit this code. I hope it will also gonna submit. I know it was a really long. You can see, guys, it successfully got submitted. I know I have mixed up some things, but believe me, I believe you guys have understood that at least the logic part, right? What actually we need to do, right? If you're not getting a implementation, don't worry about that. But at least you got the logic. That is my main motive. So I hope you understood the logic part, problem understanding part. The implementation was also really easy, but I mixed up a lot of things because big int was there, long was there. But believe me, guys, it was really hard for me as well, right? So I hope guys you learned something new in this video. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.